Hello and welcome back to section 14. In this video we'll be going over example 4, which is the last example in this handout. So this example we're going to be again solving for the natural response of a circuit, but we're going to use a different method this time. That method is going to be to find the decay rate, which we've been calling the root. So if you remember back in the second example, we had a 1/16. And I told you that 16 came from the 2 ohm resistor and the 8 farad capacitor. If you multiply them together, you get 16. So that's what the time constant method does. So you can see here we have two equations. Tau equals L over R equivalent, and tau equals R equivalent times C. So we're going to use that to find our root, or our rate of decay, which we've been calling S1. So let's look at our problem here. So we have a 3 ohm resistor, a 6 ohm resistor, 2 ohm, and a 24 Henry capacitor. We're going to find I of t for t greater than 0. And the first thing we want to do when we, let's make a note of those. We have tau is equal to R equivalent times C. Tau is equal to L. Check this. Yes. Sorry. L over R. L divided by R equivalent. And tau is actually equal to S. So if -1 over tau is equal to S1, which has been in our equation, x natural equal to A e to the S1 t. So that's where the relationship is. We can find S1 by finding tau, and tau is equal to just the components in the circuit, either the capacitor or the inductor, and the equivalent resistance. So that should give you a hint as to what we're going to do next. We have some resistors, but they're not all together, so we need to combine them. So the first thing you do is you notice that these two are in parallel. So you combine those. So if you do the math, you're going to find out that this is a 2 ohm resistor, 1/3 and 1/6 and all that stuff. So let's redraw that circuit real quick. Be careful that your inductors do not look like resistors. So this is our 2 ohm up here, and this is the 2 ohm we just found. So when I combine these two, I get 4 ohms. So our new circuit we have 24 Henry, and this is, 4 ohms. And then let's label our I. So this is the current that we're trying to find. Generally, you're going to try to find the current through the energy storage element, but you could find it other places in the circuit. So when I find the current through the energy storage element, we know that it's going to take the form I of t equal to I particular plus I natural. We don't see any current sources or voltage sources in here, which tells us that I particular is going to go to 0. We know that I natural is going to take the form of our A e to the S1t. So then our challenge becomes finding A and S1. So last time, in example 3, we looked at finding S1 using substitution if we have a differential equation. So the beauty of the time constant method is we don't have to write out the differential equation. Instead, we're going to say that S1 is equal to -1 over tau, and we're going to find tau by just combining our components algebraically. So we have a resistor and an inductor, so therefore we're going to use this equation, L over R equivalent. So our inductance, L over R. In this case we're going to use RE. So our inductance is 24. Our equivalent resistance is 4. So that simplifies down to 6. Which means that S1, let me scoot this up for you guys, is equal to negative 1 divided by 6. And so we can bring our equation back down. I of t is equal to A e to the negative 1/6 times t for t greater than 0. We'll write that at the very end. So we found S1, and again, the last thing you always want to find is A, our constant. Our constant is based on our initial condition. So if you read the problem, it tells you that I of 0 plus is equal to 10 amps, which means that we, oops, sorry, you can't see that, which means that we can just plug in 0 for our equation. So we know that I of 0 is equal to 10. It is also equal to A e to the negative 1/6 times 0, which is just going to make us have e to the 0, which is 1. So therefore, A is equal to 10. And that means we are done. We just write out our function here. So our current I of t will be modeled using 10 e to the negative t over 6 for t greater than 0. All right. If you have any questions, feel free to hop into Canvas or Discord and send me a message. Otherwise, see you next section.